Supplying a detached garage or similar building with a limited number of branch circuits, such as 2 or 3, is acceptable under specific conditions outlined in the National Electrical Code, particularly when adhering to Section 225.30e. Let's explore the requirements and considerations for this type of installation. Firstly, the branch circuit supplying the detached building must originate from the same service panel. This means that all the circuits powering the detached structure should be fed from the main electrical panel serving the primary building. Secondly, the branch circuits need to be protected by a single overcurrent device, which is either a circuit breaker or a fuse, located within the service panel. The purpose of this overcurrent device is to protect the circuits from overload and short-circuit conditions, ensuring the safety of the installation. Thirdly, it is crucial that the detached building is located on the same premises as the service it is being supplied from. This typically means the detached building is on the same property or lot as the main building. Now, let's address the importance of documentation. A document must be placed on the door of the main electrical panel. This document should clearly state that 2 or 3 branch circuits are supplying power to the detached building. Furthermore, the document should list the specific circuit breakers that need to be turned off to completely disconnect the power supply to the detached building. This is vital for safety during maintenance, repairs, or in emergency situations. The document can include other important information, such as lockout procedures for the breakers. Lockout procedures involve using a physical locking mechanism to prevent the breakers from being accidentally turned on while someone is working on the electrical system in the detached building. As the definition of a document indicates, it is essentially a writing that contains information. Therefore, the document we've described would indeed satisfy the code's requirement for providing information about the circuits supplying the detached building. Using Section 225.30e of the National Electrical Code is acceptable in this scenario. This particular section allows for the installation of 2 or 3 branch circuits from a single service panel to supply a detached building or structure. However, it is worth noting that this code section does not explicitly mandate the placement of a document on the door of the main panel. The requirement for the document often stems from best practices and local electrical codes or interpretations. It is important to highlight that the maximum load connected to the branch circuits must never exceed the ampacity of the overcurrent device protecting those circuits. Ampacity refers to the current carrying capacity of a conductor or a circuit. Overloading the circuits can lead to overheating, insulation damage, and potentially fires. In addition to these specific requirements, the branch circuits must be installed in accordance with all other applicable requirements outlined in the National Electrical Code and local electrical codes. This includes proper wiring methods, grounding, bonding, and protection against physical damage. Some additional points to consider are: firstly, the size of the conductors used for the branch circuits must be appropriate for the ampacity of the overcurrent device and the expected load. Refer to NEC Table 310.15b16 for guidance on conductor ampacity based on insulation type and temperature rating. Secondly, ensure that all wiring devices, such as receptacles and switches, are rated for the voltage and amperage of the circuits. Using devices with incorrect ratings can create a safety hazard. Thirdly, the detached building should have its own disconnecting means, typically a switch or circuit breaker, located at or near the point where the branch circuits enter the building. This allows for convenient and safe disconnection of power within the detached building. Fourthly, proper grounding and bonding are crucial for electrical safety. The grounding system should be properly connected to a grounding electrode, such as a ground rod or a metallic water pipe, and all metal enclosures and non-current carrying metal parts should be bonded together to create a low impedance path for fault current. Fifthly, consider the use of ground fault circuit interrupter, or GFCI, protection for receptacles located in damp or wet locations within the detached building, such as garages and outdoor areas. GFCI protection can help prevent electrical shock hazards. Sixthly, ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the National Electrical Code and local electrical codes. Electrical work can be dangerous, and it is important to have it done correctly to ensure safety. Seventhly, obtain all necessary permits and inspections from the local electrical authority before starting any electrical work. This helps ensure that the installation meets all applicable codes and regulations. Let's dive into a comprehensive explanation of the relevant aspects related to supplying detached buildings with a limited number of branch circuits, focusing on the National Electrical Code requirements, safety considerations, and practical tips. Firstly, NEC Article 225 outside branch circuits and feeders covers the requirements for electrical wiring and equipment installed on the exterior of buildings and structures, including detached buildings. Section 225.30, Number of supplies, specifically addresses the number of supplies permitted to a building or other structure. It states that a building or other structure shall be supplied by only one feeder or branch circuit unless permitted in 225.33. Secondly, NEC 225.30 allows for 2 or 3 branch circuits to supply a detached building under certain conditions. This exception is primarily intended for small detached structures with limited electrical loads, such as garages, sheds, or workshops. To qualify for this exception, the following conditions must be met. Firstly, the branch circuits must originate from the same service panel in the main building. This means that all the circuits supplying the detached building must be fed from a single electrical panel. Secondly, the total load in the branch circuit must not exceed the ampacity of the service supplying the main building. This ensures that the service has sufficient capacity to handle the additional load of the detached building. Thirdly, the branch circuits must be protected by overcurrent devices, circuit breakers, or fuses in the service panel. The overcurrent devices must be sized appropriately for the ampacity of the conductors and the load served. Fourthly, the wiring methods used for the branch circuits must comply with the requirements of the NEC for outdoor wiring. This typically involves using conductors listed for wet locations and protecting them from physical damage. Fifthly, a disconnecting means must be provided at the detached building to disconnect all ungrounded conductors. This disconnecting means can be a switch or circuit breaker located at or near the point where the branch circuits enter the building. Thirdly, documentation is a critical aspect of supplying detached buildings with a limited number of branch circuits. While the NEC does not explicitly require a document to be placed on the door of the main panel, it is a recommended best practice and may be required by local electrical codes or interpretations. The document should include the following information. Firstly, a clear statement that the detached building is supplied by 2 or 3 branch circuits from the main panel. Secondly, a list of the specific circuit breakers in the main panel that supply the detached building. Thirdly, instructions on how to disconnect power to the detached building, including the location of the disconnecting means at the detached building. Fourthly, a warning about the potential hazards of working on electrical equipment and the importance of following safe work practices. This document should be placed in a conspicuous location, such as on the inside of the main panel door or near the disconnecting means at the detached building. It should be easily accessible to anyone who may need to work on the electrical system. Fourthly, safety is of paramount importance when supplying detached buildings with electrical power. Here are some key safety considerations to keep in mind. Firstly, always to energize the branch circuits before working on any electrical equipment. Use a voltage tester to verify that the circuits are de-energized. Secondly, follow proper lockout/tagout procedures to prevent accidental re-energization of the circuits. This involves placing a lock and tag on the circuit breaker in the main panel to indicate that the circuit is being worked on. Thirdly, wear appropriate personal protective equipment, such as safety glasses and rubber gloves, when working on electrical equipment. Fourthly, never work on electrical equipment in wet or damp conditions. Fifthly, inspect the wiring and equipment regularly for signs of damage or deterioration. Replace any damaged or worn components immediately. Sixthly, if you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. Fifthly, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock hazards. Bonding ensures that all metal parts of the electrical system are connected together, which helps to create a low impedance path for fault current. The grounding system for the detached building should be connected to a grounding electrode, such as a ground rod or a metallic water pipe. All metal enclosures, such as panel boxes and equipment housings, should be bonded together using bonding jumpers. Sixthly, overcurrent protection is critical for protecting the branch circuits and equipment from overload and short-circuit conditions. The overcurrent devices, circuit breakers or fuses must be sized appropriately for the ampacity of the conductors and the load served. The NEC provides tables and guidelines for selecting the correct size of overcurrent devices. It is important to note that the overcurrent device is intended to protect the conductors, not the equipment. The equipment should have its own internal overcurrent protection, if required. Seventhly, wiring methods for outdoor branch circuits must comply with the requirements of the NEC. Conductors must be listed for wet locations and protected from physical damage. Common wiring methods for outdoor branch circuits include, firstly, rigid metal conduit or RMC, which is a heavy-duty conduit that provides excellent protection from physical damage. Secondly, intermediate metal conduit or IMC, which is a lighter weight conduit that provides good protection from physical damage. Thirdly, electrical metallic tubing or ENT, which is a thin wall conduit that is suitable for use in dry locations. Fourthly, non-metallic conduit or PVC, which is a lightweight conduit that is resistant to corrosion. Fifthly, underground feeder or UF cable, which is a direct burial cable that is suitable for use in wet locations. The choice of wiring method will depend on the specific application and the environmental conditions. Eighthly, disconnecting means is required at the detached building to disconnect all ungrounded conductors. The disconnecting means can be a switch or circuit breaker located at or near the point where the branch circuits enter the building. The disconnecting means must be readily accessible and clearly labeled to indicate its purpose. It should be capable of being locked in the open position for safety during maintenance or repairs. Ninthly, ground fault circuit interrupter or GFCI protection is required for receptacles located in certain areas of the detached building. GFCIs are designed to protect people from electrical shock hazards by detecting ground faults and interrupting the circuit. GFCIs are typically required for receptacles located in bathrooms, kitchens, garages, and outdoor areas. Tenthly, surge protection is recommended for detached buildings, especially those that contain sensitive electronic equipment. Surge protection devices or SPD can help protect equipment from damage caused by voltage surges or spikes. SPD should be installed at the main panel in the main building and at the disconnecting means in the detached building. 11thly, permits and inspections are typically required for electrical work on detached buildings. Check with the local electrical authority to determine the permit requirements and inspection procedures. Permits help ensure that the work is done safely and in accordance with the applicable codes and regulations. Inspections verify that the work has been completed correctly and that the electrical system is safe to operate. 12thly, hiring a qualified electrician is always recommended for electrical work on detached buildings. A qualified electrician has the knowledge, skills, and experience to perform the work safely and in accordance with the applicable codes and regulations. They can also help you obtain the necessary permits and inspections. Supplying a detached building with a limited number of branch circuits can be a cost-effective solution for small structures with limited electrical needs. However, it is essential to follow the requirements of the National Electrical Code, local electrical codes, and best practices to ensure the safety and reliability of the electrical system. Remember to prioritize safety, obtain the necessary permits and inspections, and hire a qualified electrician if you are not comfortable performing the work yourself. Now let's talk about specific code references related to supplying detached buildings with a limited number of branch circuits. Firstly, NEC 225.30 through D outlines other exceptions to the single supply rule, such as for fire pumps, emergency systems, and interconnected electric power production sources. These exceptions are not typically applicable to detached garages or similar small structures. Secondly, NEC 225.31 requires that the disconnecting means for a building or structure be suitable for use as service equipment. This means that the disconnecting means must be capable of interrupting the available fault current and must be marked with its short circuit current rating. Thirdly, NEC 225.32 requires that the disconnecting means be readily accessible. This means that it must be located so that it can be easily reached without having to climb over obstacles or use tools. Fourthly, NEC 225.33 requires that the disconnecting means be permanently marked to indicate its purpose. The marking must be legible and durable. Fifthly, NEC 225.34 allows the disconnecting means to consist of a circuit breaker or a switch. If a circuit breaker is used, it must be capable of being locked in the open position. Sixthly, NEC 250 covers the requirements for grounding and bonding. It specifies the types of grounding electrodes that are permitted, the methods for connecting to the grounding electrode, and the requirements for bonding metal parts of the electrical system. Seventhly, NEC 300 covers the general requirements for wiring methods. It specifies the types of conductors that are permitted, the methods for installing conductors, and the requirements for protecting conductors from physical damage. Eighthly, NEC 310 covers the requirements for conductors for general wiring. It specifies the ampacity of conductors, the insulation types that are permitted, and the requirements for certain conductors in certain conditions. Ninthly, NEC 406 covers the requirements for receptacles, cord connectors, and attachment plugs or cord sets. It specifies the types of receptacles that are permitted, the requirements for GFCI protection, and the requirements for tamper-resistant receptacles. Tenthly, NEC 408 covers the requirements for switchboards, switchgear, and panel boards. It specifies the requirements for the construction, installation, and overcurrent protection of these devices. 11thly, always consult the latest edition of the National Electrical Code and local electrical codes for the most up-to-date requirements. Electrical codes are subject to change, and it is important to stay informed of the latest regulations. In conclusion, supplying a detached building with a limited number of branch circuits requires careful planning and attention to detail. By following the requirements of the National Electrical Code, local electrical codes, and best practices, you can ensure the safety and reliability of the electrical system. Remember to prioritize safety, obtain the necessary permits and inspections, and hire a qualified electrician if you are not comfortable performing the work yourself. If you are unsure about any aspect of the installation, it is always best to consult with a qualified electrician or electrical inspector.